Yeah, so at the end of this you're gonna take a quiz.
Oh, okay.
Yes, today. Like literally in 30 minutes. Okay.
I've never studied.
Okay, you guys ready?
No.
We gotta hustle. You're in teams.
Teams?
Yeah.
This is so stressful. Hold on, I just need to do a partner quiz.
Huh?
Can you do a partner quiz?
Oh no.
You do those in English, and like if you don't know what you're talking about, you get a good person and like save like partner quizzes.
Oh yeah, that makes sense.
Are you lucky?
You can use notes. So just grab a piece of paper and start writing. Are you ready? Here we go.
You're not even ready.
Okay, for number 1, it says write g of x in terms of f of x after performing a horizontal stretch by a factor of 4 and translating it up 4 units. Okay, so horizontal stretch. How do I do a horizontal stretch? By a factor of 4. Where is the horizontal stuff happen? Inside the parentheses, right? Okay, so if I have a horizontal stretch of a factor of 4, what's going to be inside the parentheses? Is it going to be 4 times x or x divided by 4? Or 1 over 4, that works too. So you can do 1/4 x, okay, to do horizontal stretch. Remember, it's always opposite of the way your brain thinks. If we are going to move up 3 units, what are we going to have? Plus 3, and where is it going to be? Outside parentheses. I feel like we've been here before. Okay, everybody okay with question number 1? Okay. Question 2, find the inverse. How do I find the inverse of any function? Okay, good. So all I'm going to do is do x equals -6 times y plus 2, and then what do I do from there? Okay, good. So I'm going to isolate my y, subtract 2, so I have x minus 2 equals -6y, then what? Divide by -6. If you guys can't get this on your tablets, just look up. Don't freak out. You can still see what I'm doing. Okay, so my inverse function is x minus 2 over -6. Everybody good there? So far, so good? Easy peasy. All right, which of the following functions is not always true? If a function contains the origin, then the inverse function contains the origin. So what is the point or the ordered pair for the origin? 0, 0. So how do you decide things about inverses when points are involved? You switch the x and the y, right? So what would the inverse point of 0, 0 be? 0, 0. So would you agree with this statement or not? I would agree with this. So this is a true statement. Okay, for B, if the function has 3 x-intercepts, then the inverse function has 3 y-intercepts. What do you think about that? Okay, that would be true, right? For the same reason, if my x-intercept was, I don't know, 2, 0, the inverse of that would be 0, 2, right? So this is also a true statement. So we could probably circle C and move on to the next one, right? But we're smarter than that. We're going to read it just to make sure we understand. If the slope of a linear function is less than 1, then the slope of its inverse is greater than 1. Okay, how could we decide that, or maybe use an example to think about it? Like, what if we went back to this question right back here? Okay, so the slope of the original function was what? 6. And the inverse was 1/6. 1/6. Okay, so If the slope of a linear function is less than 1, then its slope of the inverse is greater than 1. So it all depends on negative versus negative, right? Those both were less than 1. So that's false. Question number 2 is a counterexample. All right, write the function, I almost said a bad word. Ooh. Write the function as a set of ordered pairs, then write the inverse function as a set of ordered pairs. So, what's my function? My function, what are those points? So all we're going to do is like basically list the points. Can I do this quickly? Would you agree with 3, 4? 2, 4? 1, 3? -2, -1, -3, -2, and -4, -1. We all agree with those? So my inverse points would be what? Yes? No, you don't have to write it on your tablets. Just pay attention, yeah. So you can use this to help you do well on the quiz. I'm not going to grade this as an assignment. This just looks like the test you're going to take for the quiz. So what are the ordered pairs? 4, 3, 4, 2, 3, 1, 2. This is like tedious. I feel like they should have just done 4 points or something. There we go. Easy peasy there. Finding points or inverses with ordered pairs, check. That's easy. Okay. What statement about the function x cubed is true? So before we do the true or false, let's think about what x cubed looks like. Tell me about x cubed. What does it look like? I love how you guys say John Travolta's. Cute. All right, so A, which one is, what are we doing true? Okay, so the function is positive where x values are less than 0. No, because it's below the x-axis in those places, so that's not true. The function never increases. It always increases. False statement. This function is odd. That is true. You remember what an odd function is? Whoa. Reflected over the origin. Very good. All right, here comes a really good question about a rectangular prism. What? Why are you guys? Okay. All right, so we have the ice chest shaped like a rectangular prism holds 3,000 cubic inches of crushed ice. The length of the chest. Ooh, do you want a picture? No? The length of the chest is 4 inches greater, so equals 4 inches greater than the width. You see how I pull that statement straight out? The length is 4 inches greater than the width. Okay, and the height is 2 inches less than the width. So the height is 2 inches less. How would you do 2 inches less? Oh yeah, it kind of just showed us that. Anyway, good to know, in case they don't. Graph the cubic function and model the situation. Use your graph to estimate the width of the chest. Okay, so how would we go about graphing this particular function right here? Okay, we probably should, huh? So, first of all, what are my x-intercepts? Let's start with that. -4, 2, and 0. There we go. Okay, so why do you think that they don't go to the left? Oh yeah, right? That would make sense. Or technically a negative width, because our w's are technically our x's in this case. So we could like extend it if it helps you think visually of how this looks. So we have 0, we have 2, and we have -4. 1, 2, 3, 4. Okay. What is this function going to look like? a John Travolta, right? And it's going to cross through each of the points. Okay, his right arm is going to be up, so he's going to go up like this, down, and continue upwards. Okay, so use your graph to estimate the width of the chest. What's the key piece of information we need? Remember this right here? Okay, so we need to figure out when that is equal to 3,000. So somewhere up here, it's going to cross 3,000. I don't know where, but somewhere at some x value, it's going to cross. So how can we figure out where these two functions are going to intersect? Yeah, you're totally right. But at this point, you don't know how to solve a cubic equation, which is going to be a slight issue for you. So what you're going to want to do is solve by using a graphing calculator, right? We can solve equations by finding out where two lines intersect. Okay, so grab your calculator. You might want to follow along with this. All right, so the first thing that we're going to do is type the two equations, and notice I said two equations into our y equals. Okay, the first one is going to be our volume, so we're going to have x plus 4, and x minus 2, remembering that x is representing our width. What's my second equation going to be? 3,000. So that's going to be, we want to figure out when the volume is going to reach 3,000. Okay, so if you hit zoom 6, so you remember that we have a standard 10 by 10, because who knows who was using that graphing calculator before you. I don't know what window it is. The height of that is 10. So we need to like zoom out so that that max height value, we can see that line of 3,000. Okay, so what we're going to do, instead of zooming out like 500 times until we finally can see it, we're going to go into the window and adjust it manually. That way it won't take so long. So do you see the window button? Right there, up by the y equals. Okay, if we want to go way up higher, is that going to be an x or a y? Okay, and it's going to be a y maximum, right? So we're going to go down to the y max, and we want to go slightly above 3,000. So let's say 3,000. You guys are no help. 3,500. I don't know, I'm going to throw that out. And I'm going to go by a scale of 1,000s, just so that my axes don't look like super thick lines. Now the other thing is that I probably need to go to the right more. Okay, so I'm going to go back up to my x, and I want to go to the right. How far do you think I need to go? 50? Let's take a stab at 50. All right, so now if we hit graph, there's that right arm of the John Travolta. Remember, we're zoomed out so far that you can't really see his John Travolta look anymore. So now we can see that intersection. Okay, so you ready for this? How do you find the intersection between two graphs? The calculator can find it for us. Second trace, good. So second trace, and we're going to choose number 5, and we're going to hit enter, enter, enter. Okay, so you can see 13.962, and then the y value is magically 3,000, which it should be. We should have known that. So the width that we are looking for is 13.96. 0.96. Oh, I got you. And we should label this in inches. Okay, so second trace, option 5, enter, enter, enter. Ooh, that was a good one. Okay, moving on to number 7. Okay, so this one says, how is the graph of g of x related to f of x? So if I have a -3 inside the parentheses, tell me what direction is this function moving? It's going to the right. Good. Okay, so I should look at that and say, okay, I know it's going to the right 3. So now, A, the graph of g of x is translated to the graph down 3. A. Sorry, I kind of skipped over a few words there. So not A, right? Not C, but B, right? To the right. No, just kidding. I can't read. My bad. Right. I got this. Okay. How about number 8? If you have a +2 at the end of the function, what happens? Up 2. So which one is up 2? Let's see. That's A, up 2. Easy peasy there. Love those translations. Man, fun stuff. Okay. Ooh, okay, so here's another cubic function in our vertex form. Hopefully you remember this. Yeah. Okay, remember that HK is my vertex, right? So that's like where the wiggle, like where his neck sits on the John Travolta. I know that sounds kind of gruesome, but which point on here is my vertex? The 2, 3, right? So that's like the middle of where John sits, right? Oops, don't draw his hands. He already has hands. Okay, so that is going to be my h and my k, right? So 2 is my h, 3 is my k. What's the one variable that I'm missing for that equation? The a. So how do I go about finding a? Go ahead, John. Plug in what? Good, because that's an x and a y, right? Okay, so we can use those pieces to plug it in to find our equation. Okay, so as of right now, I know it's like y equals a times x, let's see, -2 cubed plus 3, right? So all I have to do is let's just take the point 3, 4. I could use 1, 2 also. Maybe that would have been an easier point to use because they're smaller numbers, but either way will come out the same. So my y value is what? 4. So we're going to 4 equals, a is what we're looking for. What's the x value of the point? 3. So 3 minus 2 cubed plus 3. Now I have an algebraic equation that I can solve. So how would I solve this? Good, -3. Okay, I can also simplify the inside of the parentheses. What's 3 minus, oh my gosh, 3 minus 2 cubed? Good, 1. So my a value is 1. Okay, so my equation would be, I could say 1. Do I need to say 1 when it's a 1? No, but if you want to, if you feel better about it, like, yeah, look, I found the a value, then that's fine with me. How do we do there? That one makes sense? I feel like that's like the hardest kind of question that this stuff has. Yeah, I mean, you got to do a little algebra. Use a graphing calculator to graph the function, if necessary. We don't need one. Then use the graph to determine the turning points. Oh, I guess, well, I don't know. It's up to you. Do you want to use a graphing calculator or?
Yeah.
Okay. Okay, we got to use our Wabbit, or not, sorry, TI-84, whatever this is called, this calculator. And turn it on is a good start. There we go. All right, so we're going to type these in. So we have x squared times the quantity x plus 3. Hit zoom 6, so we go back to a standard 10 by 10, by the way. Okay, we should know we're going to see a John Travolta. It's going to bounce at 0. It's going to cross at -3. So tell me, how many turning points do you see? 2 turning points, and tell me about your max and min. What kind are they? Are they local or global? Both are local. Good. Okay, so remember, local is just the max and min. Global is like the absolute max or min of your entire function. Okay, so 2 turning points. Okay, I'm gonna get lazy here. Turning points. 1 local max, 1 local min. Okay. 11, ready? Can I do this without a calculator? No? Okay, you guys do the calculator. I'm not gonna do it. So we got -1, we got +1, we've got -2. So it's going to bounce at -1, x to the 4th, both hands are up. So we're going to go, where are we bouncing at? 1, -1. And crossing. How'd I do? Agreed? Perfect W. W-ish looking thing. Okay, so tell me about how many turning points. 3 turning points. Max mins. Does this one go way lower? Way lower. Okay, so I would say 1 local min, right? This is a local min right here. Local min. What's this one right here? 1 local max. And this one way down here, that's the lowest of the whole function. 1 global min. Good there? Okay, for number 12, where are my 3 zeros? 0, -1, 2. What kind of function is this? X to the 3rd, so it looks like a John Travolta. We're crossing at all 3 places. Right arm is up. Right? Good, good, good. This is so easy, you guys are falling asleep now. Okay, ABC, which one is the right one? Let's see, we have a 0 at -3, -1, +2. Everybody agree with C? Perfect. Good. Okay, I'm going to skip 14 because it's probably going to be extra credit on your test. Number 15.
Is there going to be
Oh, sorry, I didn't say that very loud. Yeah, it's probably going to be extra credit. Smile, extra credit. But we already did. We did like 2 of them already. Oh, they even give you this equation. Look at that. Volumes, maxes. Graph in your calculator. Find your max, right? You got it, you got it. Okay, assume that the constant factor A is 1 or -1. So we're just writing the equation of this. So tell me what the equation, what happens at -1? We got a bounce, bless you. So we could have X, what's my quantity? +1, and what's my exponent? Squared, 4th, 6th, 10th, 2,222. Any even number. What's my second quantity? X minus 2 to which power? Actually, I lied about that whole exponential thing. Cubic, we only can have 3, so it couldn't be any even number. It has to be 2, and it has to be 1, because otherwise it wouldn't be a cubic, it would be like a quintic. What? Oh, 2. Thank you. Sorry. Oh. 2. Sorry. Good catch. Thank you. That's a 2, not a 1. Good call. Are we done? Oh, we got this. Okay, done and done. Put your laptops away. Game time.